Hello student, welcome to online tutorial session. I hope you have seen the first video lecture on the topic flowchart and algorithm part. Okay, I hope you got the PDF as well. You follow the PDF. It is a complete PDF of 25 pages. So for each lecture session, I will upload the same PDF, and whatever topic is up cover, you just up to that day by day you update your copy by writing those content in the PDF. Okay, so today we will learn. Previously we have discussed about what is algorithm, what are the characteristics of algorithm. Today we will discuss about how to write the algorithms. Okay, so first thing I have mentioned you that it is a sequence of instruction set, so you have to follow the stepwise approach. So first thing first is that we have to follow the stepwise approach. Step 1, define your algorithm inputs. So in the first step, what we will do, so what approach we are following? Step by step approach. So what is the first thing that we will do? So the first thing that we will do, that is that we have to declare the inputs. Declare the inputs. Suppose I want to add two numbers. So if I want to add two numbers, so what about the input? Maybe two variable value I have to give. Suppose variable is A and another variable is B. So we have to, and what value it will possess actually, that one. Maybe A equals to 10, B equals to 20. So this kind of a declare and definition of an input variable we have to give. Okay. Now coming to the next step, define the variables. Okay, so second step is says define the variable. So define the variable. Algorithm variables allow the user, if it is for more than one place, we can define two variables for rectangle height and rectangle width as height and width, or we should be meaningful variable instead of HW, height and width. It means you have to define in which variable. Suppose we want to find out the perimeter of a rectangle. Okay, so perimeter of a rectangle, if you want to find, then height and width is more important required. So whatever variable you are using, try to name it appropriately so that it will be easier for the person to understand the algorithm. Suppose for a height of a height of a rectangle, I am declaring the variable as A, and for width I am declaring it as B. So it will be difficult to understand what is A and B. But instead of A, if we write HIEGHT, height, as a variable name, and this one instead of B, if I write width as a variable name, then it will be easily understandable for a person to identify that this height is a variable to where actually we are putting the height value of a rectangle. So like this. Okay, now third point is coming. Third point is saying outline the algorithm operation. So what operation we are doing, that uses a variable for computation purpose. Okay, so computation purpose means that what actually we are doing. Suppose previously if you add this to number, so what we will do, we will write A plus B, C equals to A plus B, because what computation value is required, we are finding out the sum of two variables. So this A is possessing 10 and this was 20. If you add, then we will store the value in C. So we have to do this computation part. Okay, or suppose perimeter or any formula, if you want to, 2 into L plus B. Okay, so this kind of a computation evaluation of operations like this we have to give in the third part. Okay, now the step is 4. Step 4 says what? Step 4 says that the output, the result of your algorithm operation. So after this operation, what we are getting, like this, here we are getting C. C. It means after adding A and B value, we are getting the C value. C is your final outcome, and that final outcome you have to write down. So this is how we can write an algorithm. Okay. Now coming to the topic, that is flowchart. Coming to the flow chart. So what is actually the flow chart? The first design of a flow chart goes back in the year 1945, which was designed by John von Neumann. So you know, can you tell me the other invention of a John von Neumann? John von Neumann actually designed this architecture of a modern computer. The memory concept is introduced by him in the computer system. Previously, the memory unit part is not present over here, but the John von Neumann architecture design, in this particular design, he introduced the fifth element, that is a memory unit concept. Okay, so flowchart uses actually different symbols to design the solution of a problem. Okay, it is another commonly used programming tool. But actually, when you try to build up the algorithm or when you write in the program, so if you very first time, if you draw the flowchart, so it will be easier for you to write down the code and as well as write down the algorithm also. Okay, so what are the advantages we are facing over here if you using this flowchart? Flowchart is an excellent way of communicating the logic of program. So I'm saying that when you're writing a program, if you draw previously the flowchart, then it will be easier. Why it is easier? Because it is a graphical representation of a program. Graphical. So graphical means we are using symbols over here. Okay, we are using different type of symbol over here. Okay, so as we are using different symbols implies different meaning. So using different symbol, it will be easier for a person to get a concept or get information about this particular programming language. Easy and efficient to analyze the program using flowchart. During the program development cycle, the flowchart plays a blueprint. Blueprint means suppose the architecture. In case of housing complex building up. What we're doing? We are doing the blueprint, which is preliminary stages sketching. You can know. So when we are developing a particular program or something, so blueprint is required, preliminary stage, concept analysis and everything. Through the flowchart, we are doing this. So, okay, after successfully development of the program, it needs a continuous timely maintenance of the during the course of operation. The flowchart also make the program or the system maintenance easier, and it is an easy way to convert flowchart to any other problem. So flowchart is you can say a universal representation. From the flowchart you can write, and if the logic is clear to you, then from the flowchart you can write a code in different programming language. Okay. Okay, so now what is a flowchart? What are the advantages? Now again I'm defining the definition. The flowchart is a diagrammatic or a graphical representation of sequence of steps. Okay, so graphical representation, and number two is a sequence also. Sequence of uh, steps are actually computed or considered over here to solve the problem. Okay, so there are different type of why it is graphical representation. Just now I have explained there is a symbols are used. Hope from here also you are able to see this symbol as well. Okay, this oval symbol you are able to see this one. Oval symbol is represent start and end of a flowchart. Actually, flowchart it also follows the stepwise approach. Okay, and it is follows the symbol as well. This too it is follow, so you know that very well. So right now what symbols we are it is following. Now first the symbol that is it is following, it is the oval symbol. Okay, oval one. This represents start and end of a stop of a process. Okay, this oval represents start and or end of a process. Number two, that is a parallelogram. Please bear with my drawing, maybe it is not perfect. Okay, I have some shapes, right? Parallelogram is not there. Okay, parallelogram is there. So this parallelogram is actually used for taking input and output. We will put input over here as well as the output. Okay, so first oval to represent start and end or stop of a process, the flowchart, and the second number 2 is used. This parallelogram is used to take input as well as to print the output. Okay, I'm clearing these two. Now coming to the next one, very quickly, that is the rectangle one. So rectangle is used for arithmetic operation. Like this rectangle used to do arithmetic, like a plus b equals to c, or a into b equals to c, this kind of a arithmetic operation. Number 3. Number 4 is the diamond shape. Diamond shape is for condition checking. A is greater than B or not. A is less than C or not. Something, the operation, the logical operation, greater than, less than, equals to, actually for condition checking. You can write down this as a condition checking one symbol. This is what the 5th one. Okay, I'm erasing this one. Now the arrows are different arrows are there. Okay, so different arrows are denoting the flow actually. So there's a maybe upper part arrow, maybe right hand side arrow, left hand side, and downwards. These arrows are represents the data flow. Okay, from where to where data are flowing, it represents that one. Okay, then there is a circle option is there. Circle option is a page connector. Okay, it will connect one page with the another one. Okay, so this one circle is used for page connector. Okay, another way there is a offbeat. This structure is also used for page connector. Okay, so if a process is predefined, already defined, then this kind of a symbol is we are doing. And if we are doing this, this is a comment. It means whatever we are writing under this, it will not consider. Okay, and this kind of a symbol is known as a processor symbol. This kind of a symbol, this all these 3 of these symbols we are not generally using in the flow chart. I hope the symbols and the meaning of the symbols and what is flowchart is clear to you. Okay, so I'm ending my lecture over here. Thank you, students.